Now let's talk about Gephi. Okay, it's compared to Python coding, it's a bit easier one to learn. Yeah, I'm recording it. I think I'm recording it. So Gephi is a visualization tool. It's not a part of Python. Visualization of the social networks. Networks looks like this. This. This is not some chemical thing. This is a social network thing. For example, if you have if you are able to if you manage to download or collect a lot of social network data like people's name and which pair of people are friends, then you are able to create some visualize some figures like this. So like these people, they're not together; they're isolated. These people, they have very close relationship. They probably uh, are in the same social society, the student union or something. So how do you visualize this? If you want to calculate some features, for example, um, which nodes. So one point, every point is called a node, N-O-D-E, a node in the social network. And the line connecting them is called an edge, E-D-G-E, an edge is the terms. Okay. So for the calculation or the computation of the characteristics of the nodes, for example, which nodes have more connections or whether they're connected to more important nodes. The importance of the nodes is defined by the number and the importance of the nodes that it connects to. Then this is it's an iteration. Well, the to define the importance of the nodes that connected to this node, you also need to know the other nodes connected to the nodes that you connected to. So to calculate these parameters and variables, some of them, like for example, the importance is called eigenvector centrality. To calculate this, you can use a package in Python called networkx. Okay, it's not just for um, the calculation of the importance, but also for the other calculations. The networkx is not that easy to use for visualization. Well, it probably is easier now, but we are introducing another one to use, which is called Gephi. Please now download Gephi. Gephi is open source and multi-platform software. If I remember right, it should be written in Java, but I could be wrong. So, for example, this is a hashtag of Twitter. Using Gephi, you don't have to code really. Every button is a function that has been used, has been uh, written into a button, so you can basically just click the button and complete the visualization task. We are using two files to complete this task. So the first one is, so these are my PhD. This is a part of my PhD thesis. So my to simply introduce my PhD thesis, I was using the social network to actually the network of interlocking directors. The interlocking director is defined as one director sitting on the boards of multiple companies. So the multiple companies may share some insider information through this common director. So through an analysis of the interlocking director network, we find that I find that the the uh, the Chinese firms are listed in the Nasdaq or NYSE can be categorized into some very honest groups and some fraudulent groups. So for the fraudulent groups, if you identify them, they're in the periphery area of the whole social network. So it's easier for the regulators to identify. I think it can. I have some evidence proving that it's it facilitates the regulators to identify the fraudulent companies. But let's see. First, they can ignore all of these. These are my calculated parameters of the social network. You don't really need them. For example, I can basically just delete them for now. Like they have a lot of parameters. If you want to understand or learn them, then you can check the online resources to learn what they mean. Here, I for the nodes, I only need to have the ID and the ID's label. So for each ID, it's the ID is denoted in numbers. It's a numerical value, and the label and the company name is a string. Okay. Then we have its degree. We don't need to have its degree. The degree is calculated by the software. The degree means the number of companies that this company is connected to. So we don't have to have them for now. Okay. Then the other one is called the edge. The other file is called edge. The edge has the source and target. It starts from one company's ID to another company's ID through some common interlocking directory. If you check online, you can find all of them are very famous the figures in the financial industry. So now these are our input files. These are our input files. To use Gephi, we just launched a new project. Well, I figure that you have already downloaded the Gephi. If you download Gephi, you download it, then you open it. New project. For the new project, you first click the data laboratory, not overview. First click the data laboratory and you click nodes, then import the spreadsheet. It's when you click the import spreadsheet, it's kind of like you write a Python or whatever or Java code, say import from somewhere. Okay, import it. Import it from what is the location of this folder? Um, Frankie, where's your folder? Yeah, where is the folder?
Do you know the Galaxy folder?
Yeah, I want to get the files folder. Okay. No, not the Gephi folder, the nodes and so the files folder.
Wow, yes. There is a Galaxy file here.
Yeah, I think it's this one. Thank you. So you import nodes. Oh, someone says like when he installed Gephi, it tells you that you cannot find Java 1.8 or higher. Then you first need to upgrade your Java. You upgrade your Java, then you install Gephi. Okay. Um, then I import it. Okay, I will have the ID. Now I also import. Remember that when you import them, you better be very careful that you import it as an edge file. Okay, the edge file. Okay, so you got a node file and you got the edge file. So this ID is different from the node ID. The edge's ID is the ID of this edge. Okay, so the software can identify the edge as different labels. And for the nodes ID, it has no, I think for the nodes ID I imported the wrong one. It should be the nodes, and this should be the nodes, and it's yeah, 228. Yes, yep, it should be right. Let me import it again. Hmm. I have no idea what's going on here. Let me try whether it can be. Well, it can be formatted here, but it doesn't have a the data laboratory. It doesn't. Oh, I see what's going on. I see what's going on. Oh, I'm sorry. I see what's going on. Here the edge. I should not. I see what's going on. I got it wrong. So I imported the nodes. I should also import the edge into the same workspace, not the other one, not to get the new one. Next, finish the existing, append to the existing workspace. Yes, now I'm right. Okay. um, then then you see this. Okay, this is a very messy network. So the very messy network, you can change it here, you can do something here, and you can do something here. But how do you make it something that you want to see? That you can have different layouts. For example, you can try to use something like a random layout. Well, if you use random, it really gives you some random thing. Like you have,
You calculate it.
for example, if you use a Hu Yifan, some for the layouts, you will get something like this. Well, my favorite layout is called Force Atlas 2. Force Atlas uses a very special algorithm to calculate its positions. So I can make this link lock mode and prevent overlap and display hubs. If you use display hubs, it's gonna make the hubs far away from each other so you can see them clearly. Um, or I can make the gravity a little bit smaller. Okay. So this Force Atlas uh, uh, layout has some features. So assume that there is a gravity here, but there was a force driven every nodes out. But when every node is being driven outward, the gravity will push it inward. So if a node is driven by different other nodes from different directions, it's going to be put in the central area. If it is not, for example, like this group of nodes, they are closely connected with each other, but they are not very connected with the nodes in the central area. So it's going to be put in the periphery area. Simply speaking, all of these, every node's position, where it is, and the edge's position are being calculated. Okay. So basically, my work just says these my dissertation says like these companies, they have a much higher probability of being fraudulent companies doing the illegal things because they simply just coordinate together through the common interlocking director, but they don't share a lot of information with the other firms. So they are not very easy to be. It's easier for them to hide their information, not being um, uh, very transparently by the markets. So there are other things like in this software, you can show the NOS labels, so you can see each company's name, and you can show the even the labels of the person that connects the interlocking director that connects them. Okay, and you can also calculate the different attributes and the parameters, statistics for the NOS. For example, you can calculate the modularity. What is modularity? Modularity is a classes. Um, so, for example, in the network theory, if you want to know, visually you can see that these nodes they are together. These are together, and these are together. So these should not be in the same group of these firms. But how do you mathematically calculate them? You can calculate a modularity class to assign the values so that you can divide these nodes into different classes based on the modularity value. Okay, you can also calculate the page rank. Page rank is a very special. It's not a very special. It's a special kind of centrality um, that Google uses early age to sort the importance of the web pages, because you can imagine that if you treat each web page as a node, okay, each node is a web page, and a web page has a link to the other web page, then we treat this as a edge connecting one web page to another. So such network can be visualized, or if you don't want to visualize, it's fine. It's hard to visualize such a big network. You can also just calculate the centrality of each node so that you can know, or each web page, so you can rank them, then get the web page of the highest, the web pages of the highest centrality or importance, so that you can sort the web pages and find out whatever you wanna search. Okay, so if you calculate the average degree, you can picture or change the appearance of the knots and the edges based on the things that you calculated. For example, we do this by color. We can also do this by the size, or maybe I make it bigger. Yeah. So the knots with bigger size are those with more connections, and I can also calculate the modularity and picture them based on the different modularity class. See, now you easily see these firms are together because they're in the same color, and these are together. These should be denoted in the same. They'll be categorized in the same group. It's a little bit a very simple clustering um, calculation. It's a clustering algorithm, I guess. I don't know this very specific algorithm in the modularity class calculation, but I don't think it's very hard. Um, so whenever you do this, you can do the preview. You can refresh it, and you get this. And here you can see that you get the curly edge. You can turn it off and show just the curved edge. Well, you can show the straight edge, and Show edges. You can show the labels. Okay. So that you will see the network, the director network of the cross-listed companies, the international listed Chinese companies. If you don't want a proportional size, you can do this. And you see, it's a proportional size of the tickers. So I think this is a nice one, based on my personal taste. Um, yep, and I can just download it, save it in the PDF. Maybe I can save it. So when I open it, you will see this. Okay, so you can visualize the network in a very simple way. So of course, you can change the color and the size of the nodes according to your own taste. Yeah, this is what we're up to. Okay, this is the end of the Gephi. So what you want to do as a homework is to find out the social network, and you better calculate the different parameters. And the final thing is to visualize them and export a PDF. Okay, let me finish the recording.